Hi all the students. Today we are going to study fiber optics in guided media. So another kind of guided transmission media or a wired transmission media that we will discuss today is the fiber optics. Now fiber optics has optical transmission that there are strands of glass which are known as the fibers optics. So optical transmission is there. So what are the three main components or three main elements of optical transmission? The first component is your light source or the source of light from where the light comes. Then you have the transmission medium which is transmitting the actual data, and then you have a detector which is detecting the light pulse, right? So these are the three important components of an optical transmission used by fiber optics. Now the pulse of light is indicated by a 1 bit. So whenever there is a pulse of light, it is indicated as a bit 1, and absence of light is indicated by a 0 bit. So 0 bit means there is no light and 1 bit means that there is a pulse of light. Now what is the actual transmission medium? The actual transmission medium is a fiber, is a glass fiber, and which is ultra thin. So a very thin or an ultra thin fiber of glass is the actual transmission medium which is used in fiber optics, and it is thinner than a human hair. So you can imagine how fine this fiber strand or this strand or fiber of glass would be. It is thinner than a human hair, so it is a very fine or an ultra thin fiber of glass, right? Now this is coated with refractive medium. The surface of the glass strand or the fiber of glass is coated with a refractive medium. Now refractive means it does not go out, it remains inside. So hence the purpose here is to keep the light within the fiber of within the glass fiber. So hence it is coated with a refractive medium so that it does not reflect outside the glass strand. Now as I told you, there are three components: the transmission medium, the light source, and the detector. So when the light falls through the light source, so the detector is generating an electric pulse then. So there is a light source, and when this light source is usually provided by a laser or a LED. So a light source when shows light into the fiber strand, the detector generates an electrical pulse when the light falls on it, right? So whenever the light falls on the detector, it will generate an electric pulse or an electrical pulse. So this light, as I told you, is either provided by the laser or LED in most of the cases, is shown into the fiber strand. That means this light falls into the fiber strand or the glass fiber, then it travels along the fiber strand. So if it is a long fiber strand, and the light falls on one end of the fiber strand, and then it travels along the strand, and the refractive layer prevents it from escaping. That is the main reason of having a refractive coating on the surface of the fiber strand, so that the light which falls on the glass fiber does not escape, and this light travels along the length of the fiber strand. Okay, so now this is how basically your optical fiber looks like. This is the actual transmission medium, the core or the glass that you can see here. The transparent one, which is called the core or the glass, is the actual transmission medium, right? And this is coated with a refractive material so that the light which falls on one end does not escape and travels through the length of this optical fiber or this fiber strand. Then it is layered or protected with a cladding which is of glass. This layer or this cladding is made of glass, and then this cladding is further layered up with a plastic coating which is usually called a jacket. So basically a glass core, which is the actual transmission medium. This glass core is the fiber of glass. Then it is protected with the cladding, which is of glass, and then the cladding is further protected or layered up with a plastic coating, which is known as the jacket, right? Now coming back to the when the light falls on one end of the glass strand, it travels along the length of the glass strand or the glass fiber, and it cannot escape the fiber because it has been coated with a refractive material, so it travels along the length of the glass fiber. Now each strand can support thousands of speech and TV channels. There can be multiple such strands of fiber, and each strand, I'm talking about a single strand, each strand can support thousands of speech and TV channels, right? Now when you attach a light source to one end of the optical fiber, right, and a detector to the other end, there is a unidirectional transmission system. Unidirectional means the data will travel only in one direction. Right. So what happens is that to the strand, if this is the strand of fiber or the glass strand, which is the actual transmission medium, then the light source falls on this particular end and the detector is on the another end, and this makes this a unidirectional transmission system. That means the data will be transmitted in one direction only. Both parties cannot transmit, only the transmission can be done from one side. So it is a unidirectional transmission system, right? This system accepts an electrical signal, converts it into a light pulse and transmits it, and then reconverts the output to an electrical signal at receiving end. Because obviously at the receiving end, what you understand is the electrical signals. What are understood are the electrical signals. So basically an electrical signal is accepted. It is with the help of a laser or light, LED then converted into a light pulse. Then this light falls on the optical fiber strand, detected by a detector, travels along the strand, and it is transmitted. And at the receiving end, this light pulse is reconverted as an electrical signal for the output at the receiving end. So that means when it gets at the other end in the form of output, it is converted back from the light pulse into the electrical signal at the receiving end. Now light pulses which are sent down a fiber spread out in the length as they propagate, right? So they spread across the length. So that means if this is the length of the optical fiber or the glass strand, this is how the light source will travel, that is across the length of the glass strand or the fiber strand, right? And this is how they propagate or travel. This spreading is called chromatic dispersion. So this kind of propagation of the light across the length of the fiber strand is known as chromatic dispersion. Alright, now coming back to the picture of the optical fiber, as I told you, the core or the core which is made up of glass is the actual transmission medium. That is, it is through this glass core or this strand of glass the data will be traveling, which is protected through a cladding, which is protected by a cladding which is made up of glass, and this cladding is further layered up and or protected with a plastic material which is called the jacket. So this is called the cladding and this is called the jacket. Now you may notice that it is quite similar to a coaxial cable or a coax as you called it, but there is no braided mesh here. The only thing that is missing here is the braided mesh. In case of coaxial cable, you must have seen that there was a copper core, then there was a cladding, then there was a braided mesh which was further layered up with the plastic jacket. But here the braided mesh is missing. Rest, it is almost similar to a coaxial cable. Now the light, as I told you in the beginning itself, it propagates through this glass core. This is the actual transmission medium. So it is quite obvious that the light will propagate through this glass core. Now in multimode fibers means this is a single glass strand you can see, or this is a single fiber of glass as you can see. But in multimode fibers you will have several such strands of glass. So that means in multimode fiber, core is typically 50 microns in diameter. The diameter, this is the diameter. So when there are multiple fibers, in such cases the diameter of this glass core or the glass strand is 50 microns. And when it is a single mode fiber, that means there is only a single strand of fiber. In that case the core is 8 to 10 microns in diameter. And clearly it's visible, you can see that this core is surrounded by a glass cladding with a lower refractive index than core to keep all light in the core. So the refractive index of this particular cladding is lower than the refractive index of the glass, so that whatever light falls on this glass remains within this particular glass core only, right? So that is the reason that the refractive index of this cladding is given less than the refractive index of the glass fiber or the glass core. And these fibers are usually grouped in bundles and then protected by an outer sheath, which is the plastic jacket, as I told you. Usually it is very rare to have a single fiber strand. These fibers are usually grouped in bundles, that is multiple fiber strands protected by an outer sheath, which is your plastic jacket, that is this plastic jacket. So this is all about optical fibers.